This video is going to be looking at the radiation team and the calculations needed for the emission. You should have 3 sheets in front of you. The information sheet, the table sheet, and finally the graph sheet. Starting with the information, on this sheet you'll see that each column is broken down and there's description for each one. We're going to be referring back to this to understand where the calculations are coming from. So take a look first. Here we go. You may see 2 separate tables. We're only going to be working on the examples and practice one. The mission one will obviously be during the mission. Alright, column A then. This one probably seems pretty straightforward, but we can double check back and take a look. Column A is the coordinated universal time, so it's just going to be your standard military time. As you start to go, you'll notice that they are in 20-minute increments. Alright, column B then. This is going to be the information that's given to you from your teams during the emission. Obviously, right now they're given. Down below in this graph, you'll see that they're blank. That's where you'll be filling in the information as you go. So first off, let's take a look. The 20-minute dose total, and these are going to be written in REMs or REMs, and it just says right here. Record the real-time dose rate data in column B. REMs are just a unit of measure scientists and health workers use to describe radiation exposure. All right, so here we go. 0.43, column C then. You'll also notice we will be graphing this column as well. They give you instructions. C plus equals B plus previous C. What? All they're referring to is going to be the columns up above here. So those aren't any numbers that you need to not memorize or anything like that. So here we go. They assume the previous dose was 0. So I'm going to simply add B plus C, which was nothing, and you still get 43 or 0.43. Next one, the dose rate. It's going to be in REMs per hour. So if you think about it, when you're dividing something by 0.33, let's think about, okay, per hour, what were our increments over here? Oh, right, every 20. So 20 goes into the hour 3 times, so we're going to be essentially multiplying it by 1/3 or dividing by 0.33. So here we go. If I take, and I'm just going to use a calculator, definitely grab one out. I'm going to have to do the B, so column B, which is 43.43, divided by 0.33 equals 1.30. And we're going to go to 2 decimal places. So that's where that number comes from right there. Next one, the time to criticality. That's going to be more described based off of this graph here. If you take a look down below, life-threatening, debilitating, and critical, that's what they're referring to. If you can see this number right here, it says 100. So that's what we're looking at when things become critical for the crew members on the spaceship. So here we go. We're going to take column E. You're going to get that from taking 100 minus C. And C then is the cumulative dose. So how far have they gotten so far? So in this case, you're going to take 100 minus C, which we had 0.43, equals 99.57, and then we divide it by the rate, which is 1.3, divided by 1.3, equals 76.59. All right, next up, or finally, I guess, we're going to be graphing column F as well. We're going to do the 24-hour projected. So F is going to be D times 24 plus C. So again, all of this is explained on your reference guide back here, is that it will talk about this column contains your prediction of the total 24-hour dose at each measurement, I guess. So again, I haven't been referring back constantly, but this information is right here to help you fully understand what's happening. So on this one, I'm simply going to take D, which was 1.3, times it by 24 hours in a day, equals 31.2 plus C, which, was 0.43, And, whoops, 31.2 plus 0.43 equals 31.63, and that's where this came from. Let's do one together and go from there. So now they've given us one more column, and let's do this third column right here. So we're at 1.67. All right, so this one's going to be the cumulative dose, so I'm going to add 1.1 plus 1.67, or 1 plus 1.67, 2.68. Okay, column D then, we're going to find it per hour, which means I want to take this number, divide it by 3, or 0.33. I have 1.67, and I'm going to divide it by 0.33, and I get 5.06. Woo, starting to get higher here. Now let's do the time to criticality. How many hours do these astronauts have left? So I'm going to take 100 minus C, which was 2.68, equals, I get 97.32, divided by D, which is 5.6, divided by 06, and I get 19.23 right here. As a reminder, 2 decimal places. The one behind it is a 3, no need to round up, but you would need to if this was a 5 or higher. And lastly, column F, the 24-hour projected, I'm going to take column D, which was 5.06. 5.06, times 24 equals 121.44 plus C, which was your cumulative, 2.68, equals 124.12. Okay, so here we go. Let's graph these now. It's going to be up to you whether you want to graph as you go or wait till the end. All right, so this first table, says right here, instructions for graphing. For the first graph, use the data from column C. Okay, so this is column C right here. All right, so column C looks like my first dose is 0.43. Okay, so at 1500, 0.43 is going to be pretty low. Right here, 1500, 0.43. That's pretty low down here. Next up at 1520, column C, 1.01. It's going to be up just slightly, but they're going to look like they're pretty close together. And lastly, 2.68. That'd be about halfway, just over halfway to 5, maybe right there. You'll notice a trend. What do you think is going to be happening? There's a little bit of prediction happening here. And then you would continually go from there. Since this is a line graph over time, since this is over time, you can create a line graph and then connect your points as you're going. The last one down here is going to be, for the second graph the data from column F. So this one is for F. Okay, so column F. First off, let's see, at 1500, we have 31.63. 1500, 31.63. I put it right on the axis right here. At 1520, it's 43.25. Getting closer, a little bit higher. And the last one we did was 124.12. Wow, so now all of a sudden we have gotten into the critical range, maybe right about there. Again, over time, so we can connect these like a line graph. Okay, so your task then would be to complete the rest of this table and then finish up the rest of your graphs. If you have questions on each column, remember you do have this instructional sheet that you can refer back to.